Formation skydiving is accomplished in a three-dimensional space. Any movement in a three-dimensional space can be defined as a combination of fundamental movements. We will refer to these fundamental movements as our degrees of freedom. These arrows show the directions we need to be able to move for successful formation skydiving. The first type of movement we need to look at is called static, in which in fact there is no movement. In other words, we are just sitting still. Next, there is translational motion, where we move our center of mass from one place to a new place. This is accomplished by using three more fundamental types of movement: forward and backwards, up and down, and sideways movement, right and left. These translational skills will allow us to place our center anywhere we want. Rotational motion is where we change heading by rotating around our center. The only rotation we need to define for formation skydiving is controlling our heading. Finally, our fundamental moves can be combined to produce more exotic types of movement. This combination of fundamentals is called superpositional movement. Learning to perform these superpositional moves should be our ultimate goal for quality formation skydiving. In our sport, like any other sport, there is a basic stance from which the moves of the game are initiated. The body position shown here illustrates an idealized, strongly stable, neutral box body position. To evaluate your neutral body position, here are some practical things to look for. First, to sit still, your neutral position must be consistent in shape. You must trust that you can be relaxed, passive, and still remain stable. Next, you want to look to see that it is generally arched so that there is a low center of gravity. This increases stability. You also need to be able to arrange your shoulder and elbow joints so that a line connecting your hands is out in front of your head. This way, you can build formations without your head getting in the way. Your stance should be wide. We can measure this by imagining a line that connects the elbows and knees, which should enclose a large area. This large base of support enhances your stability. You also want to maintain a left-right symmetry. This will keep your center of mass in the center of your base of support. You can do this by disciplining your flying style to keep your spine straight, because a curve in the spine will cause a noticeable loss of stability. Also, as part of the left-right symmetry, we should always see an equal angle under each arm and an equal angle at the bend of the knee. It should generally be considered a problem if you see your arms or legs working independently. This body position is strongly stable, which is a serious advantage to the novice skydiver. As your experience allows, and as you develop a need for it, your body position may evolve into the sportier position shown here. As you gain experience by making more jumps, this transition position can easily be superimposed on top of the strongly stable body position presented in this video.
Module 1, trimming your neutral position.
We want to use a neutral box body position in order to sit still relative to our grid. What is it exactly that our body position does that allows us to fall straight down at a constant speed? Our neutral position produces a balanced deflection of air. We call this a balanced deflection of air because we are deflecting equal amounts of air in opposite directions. Due to the left-right symmetry of our body position, we naturally have a balanced deflection of air to the left and right. The balanced deflection out of the front and back, however, results from 1. Practicing the proper body position, 2, having the proper distribution of drag on our jumpsuit, and 3, refining our individual weight and balance in order to trim our neutral position. Imagine how the airflow is deflected as it meets our body. This deflection means that there are forces that act on us as we fall. These aerodynamic forces can be rewritten into their horizontal and vertical components. Because there is a balanced deflection of air, the horizontal forces will cancel each other out. Then, the remaining components can be rewritten as a single aerodynamic force, and, not coincidentally, this force is exactly equal and opposite to the force created by our body's weight. These forces then combine to cancel each other, and it's the balance of these forces that leaves us sitting still on the grid. The first translational moves we will explore are forward and backward while staying on level. Recall that a properly trimmed neutral position produces a balanced deflection of air to the front and back. But we can change our body position in a way that gives us body pitch. This produces an asymmetrical air deflection where we are pushing more air out of the back than the front. This air deflection produces the net aerodynamic force shown here. This force can be rewritten in its vertical and horizontal components. The vertical aerodynamic force can be made to balance our body's weight. This leaves a resulting force that pushes us toward the front. We always want to achieve movement by a coordinated use of our entire body. To move forward, we can increase the drag on our lower body by extending our legs. At the same time, we can redistribute and decrease the drag in the upper body by bringing our hands back and streamlining our chest. We then have a body pitch that pushes us forward. Similarly, if we change our body position in such a way that we cause more air to be deflected out the front, then this asymmetrical air deflection ultimately causes a force that pushes us towards the rear. We can get this body pitch if we increase the drag in our upper body by de-arching above the waist and simultaneously bend our knees to decrease the drag in our lower body. We then have a body pitch that results in a backwards push. Now, let's look at how a sequence of body positions can be combined to produce a move. Move is a cycle, where we go from a neutral to a start phase and progress naturally through a coasting body position as we transition to a stop phase and finally return to neutral in order to sit still. Start, coast, stop, neutral. You will need to use this idea of start, coast, stop for every move you make. Let's now look at how to change fall rate in order to move straight up and down. We are going to use a balanced deflection of air to make these moves, but this time we will vary how much we are deflecting the air. Recall that when we have a balanced deflection of air, we can create an aerodynamic force that exactly balances our body's weight. However, by varying our body position, we can control the size of these aerodynamic forces. For example, If we arch our body more, we produce a smaller force because we only deflect the path of the air slightly. This smaller force can't quite balance our body's weight, which leaves a resulting force that accelerates us to a faster fall rate. While a slow fall position deflects the air more. This will result in a larger aerodynamic force. Because this force is greater than our body's weight, we are decelerated to a slower fall rate. Let's see how to vary the streamlining of our body to change the amount we are deflecting the air. Notice the coordinated use of the whole body, including flexing the chest and shoulders. From this point of view, we can see the articulation of the spine and coordinated use of the whole body to control fall rate. By being combined into a start, coast, stop cycle, this sequence of body positions can then be used to make distinct vertical moves. When you are turning in place, your center of mass remains in place while you change heading. Let's look at how we can use our ability to deflect air and create the forces necessary for turning in place. Recall how our neutral position causes a balanced deflection of air to the left and right. This is part of the reason that our neutral position allows us to sit still on the grid. We can change our body position in a way that produces the asymmetrical lateral deflection of air shown here. This air deflection produces these aerodynamic forces, one force acting through our upper body and the other through our lower body. Again, these forces can be rewritten into their vertical and horizontal components. When done properly, the vertical components combine to balance our body's weight. This leaves the resulting forces shown here, and because these forces do not push through our center of mass, they cause us to turn. To produce the needed lateral force in our upper body, we can bank our upper body and flex our shoulders to catch and steer more air to the side. To produce the needed lateral forces in our lower body, we need to unlevel our knees and rudder our booties to steer air to the opposite side. To initiate a turn in place, you need to use your entire body. You must coordinate your upper and lower body to deflect equal amounts of air in opposite directions at the same time. The ability to do this is required to generate a turn in place. To turn these body positions into a move, they must be combined into a start, coast, stop cycle of body positions. Remember that when initiating the stop portion of the move, you must continue to balance the use of your upper and lower body in order to remain in place while you are stopping. The final fundamental skill we are going to look at is sideways movement. You will want to learn to do these moves while staying on level and maintaining heading. To move sideways, you must change your body position from one that produces a balanced deflection of air to the left and right to a body position that produces an asymmetrical deflection of air. This asymmetric deflection of air can be made to produce the aerodynamic force shown here. Rewriting this force into component form, the vertical force once again acts to cancel our body's weight, leaving a resulting force that pushes us sideways. To produce this sideways force, we can use the same techniques that we developed to turn in place. We will push the air to the side using our upper body, and also push air in the same direction with our lower body. In order to move sideways without turning, we must learn to coordinate our upper and lower body to push the same amount of air to the same side at the same time. As with all moves, these body positions need to be combined into a start, coast, stop sequence in order to make small, controlled moves. After we have developed the ability to move forward and backward on level and straight up and straight down, we generally should be able to automatically superimpose these skills in order to have complete freedom of movement in the vertical plane shown here. Once we've developed our ability to move forward, backward, and sideways on level, we then have the ability to move from any place to any other place on the formation skydiving playing field. Notice the use of the start, coast, stop cycle of body positions and the straight line movements from place to place. In addition, we can superimpose a turn around our center to make even more exotic moves on level while still moving in a straight line from place to place. Remember that this is the skill needed in order to build formations. The ability to do superpositional moves is automatic if you can demonstrate all of the pure fundamental moves we've discussed. This is because this type of superpositional move is actually a combination of forward, backward, up, down, turning, and sideways movement skills.
The first thing in your mind needs to be what your move is. And when you're skydiving on a team and you can trust your teammates to make their move and you make yours, that's when the skydive starts to work. Until that happens, until everybody's thinking about what their move is initially, everything's perpetually wrong.